Welcome to this course. My name is Davis Bamigboye, and I'm going to be sharing with you in this presentation the topic that I've titled The Rise of the AI Business Analyst. Before I speak a lot about what that even means, I want to explain the reason why this course is necessary. If you're a business analyst and you have been required to work on gathering requirements and working with the business to help them to shape their solutions to ensure that maybe they engage in digital transformation or anything like that. If you do not understand how AI works or understand how to leverage on some of the AI tools that are out there, you are going to be behind the curve in the new world. So artificial intelligence as a tool or as a new way of working is a no-brainer. You have to know the tools that you can use to get your work done. That's on the one hand. On the other hand is in the coming years, we are going to see a whole lot more artificial intelligence baked into many vendor tools. I know for a fact that Salesforce has added AI tooling into their platform. I know Jira has done the same thing. Now, the question that would then come up is, as a business analyst, if you don't understand AI, how will you be able to handle it? The second point I want to draw out is we also want to show you that you need to know how to deliver an AI project in the new world, because if you don't, again, you are going to be left behind. So the rise of the AI business analyst is essentially a course that has been created to help you to understand the need to take AI very, very seriously. So what are we going to cover in this course? Number one, we are going to introduce you to AI. So this is going to be introductory um, perspective about artificial intelligence, the history, how it came to be, the different types of AI, and how you can learn a whole lot more about it. We're going to look at the AI life cycle. If you want to deliver an AI project, what is the life cycle that you have to go through? We're going to look at the roles of the business analyst, especially in an AI project. We're also going to look at other roles that are required to deliver an AI project. We are going to look at the AI BA deliverable matrix. This is a deliverable matrix that has been created that shows what a business analyst would do in an AI project. And finally, we are going to do a demonstration of some BA tools that you can take away and begin to implement today. Some of them, like ChatGPT, you already know about. AI. Now, when you think about the popularity of artificial intelligence in recent times, one might think AI is just a new phenomenon, but it is not. Because as a matter of fact, in the 1950s, Alan Turing raised one of the earliest questions related to the field, and he said, "Can machines think?" After that question was posted by Alan Turing, AI was born as a scientific discipline. Now, the vision for AI at that time was somewhat idealistic and ambitious. One of the things that they were trying to get at that point in time was a computer would deserve to be called intelligent if it could deceive a human being by behaving as one. So, when we look at this, the key thing to take away is there's a conversation around, can AI behave as a human being? Now, let us look at what the EU defines AI as. Now, remember that we have spoken earlier about the fact that there must be a machine that has the intelligence to behave like a human being in order for it to be called an intelligent machine. So therefore, the science of building machines that learn to mimic reasoning, decision making, and in general human-like intelligence to solve a problem, that is what artificial intelligence is meant to be. The science of building machines that learn to mimic reasoning, decision making, and in general, human-like intelligence to solve a problem. So the EU, the European Union, defined artificial intelligence as systems that perceive the environment, collect data, and interpret it to reason over knowledge inferred, make decisions, and take the best course of action to achieve a goal. Let us break that down so that we can all understand it. It's a system. That's the first step. An AI platform is a system. Now, a system means different parts working together in tandem. That's what a system means. So it's a system. But this system perceives the environment. So you place a system in an environment, it perceives the environment. The word perceive therefore suggests something that has to do with sensory collection. It's almost like something that has like the five senses of a human being, right? Can perceive the environment, collect data from that environment, interpret that data that has been collected, reason over that data, draw out some knowledge, right? And then, based on the knowledge that has been drawn out from the data that has been interpreted, would then make decisions. And then, based on making decisions, would take the best course of action to achieve a goal. So we can see, therefore, that this is probably what a human being too would do, right? You go out, you see something that you haven't seen before, you collect that information, right? You reason over it, you think about the best way of action, and then you take the best course of action for yourself. So what we're trying to do here is talk about the fact that AI, it ultimately is meant to be able to achieve that. If we get an AI platform, which is a system that can achieve or mimic human-like behavior, they will have achieved what we call full-blown artificial intelligence. So in light of that, let us look at a new term that I want to introduce you to, which is artificial general intelligence. So we have described AI as systems that are good at solving one or very few specific tasks they have been designed for. Or remember in the previous slide, we spoke about the fact that AI as a system must be able to mimic human behavior. Actually, the term used for that type of AI is artificial general intelligence. Artificial general intelligence refers to systems that equal or exceed average human intelligence, being able to solve a breadth of tasks intelligently. Now, I want you to see the difference between AI and AGI. AI are good at solving one or few specific tasks they have been designed for, which means it cannot solve a plethora of tasks. It's designed for a particular task, it gets it done. But when you have an AGI system, it's able to solve a breadth of tasks intelligently. So the good news for you and I at the moment, just at the moment, is AGI does not really exist at the moment. Real AGI does not really exist at the moment. There are a few examples of AI systems emulating human intelligence, but none have exceeded it. So we have a comparison therefore for you now on the screen between what is AI and what is AGI. AI perceives the environment, collects data, interprets it to reason over knowledge inferred, make decisions, and take the best course of action to achieve a goal. We spoke about the fact that these ones work on what they have been designed for, tasks that they have been designed for. Examples in our day that you can relate to are things like voice assistance, face recognition, personalized product recommendation, and industrial robots. So, for example, your Siri on your phone, right, listens to your voice, is an AI that listens to your voice and follows the particular command that you have given it, as long as that is what it's been designed for. Face recognition software. I know that on your iPhone now, you can essentially unlock your iPhone based on your face. There are some banks that use the face recognition AI platform to be able to do ID verification so that they can have access to, so that they can use to do KYC type transactions, right? So that's that. Personalized product recommendation, you will have, if you have Netflix, you'll have received personalized movies based on your browsing history, what you have done before. The industrial robot, well, I'm going to show you an example later how Ocado is a food delivery business here in the UK, how they use industrial robots in their warehouses to move things about in the warehouse. Even Amazon uses it. All right. Now, an example of an AGI, therefore, is, remember, AGI equals or exceeds average human intelligence. So when you have self-driving cars, that's an example of an AGI. But please remember, this is there's no such thing as a full-blown AGI, like I mentioned before. So this, what I'm calling out here, are in between. They are much more than AI. They are between AI and AGI, but we call them AGI for now. But they're not really full-blown AGI. So your generative AI, like ChatGPT, will fall in this category because they're using large language models. So I want to show you now in the next slide to look for you to take a test with me. Now, this test is essentially based on you trying to understand emerging trends that are exploiting the full potential of AI, even much more than we have now. Some have described the rise of AI as impactful as the discovery of electricity or the advent of computers. Though AI has been around in some form for many years, recent emerging trends are exploiting its full potential even more. From the list below, I want you to choose 2 applications and trends that you will consider good examples of important AI advances in recent times. Number 1, Netflix product recommendations. Number 2, generating codes that describes step by step how to build a website. Number 3, autonomous self-driving cars. Number 4, predicting future storms probability based on historical weather data. Let's just look at the answer in the next slide. The 2 highlighted in this slide are the ones that show us good advancement in recent times. Number 1, being able to generate codes that describe step by step how to build a website. Also, autonomous self-driving cars. Product recommendation has been around for years. I remember many years ago, probably about 18 years ago, thereabout, I was working for a company called the AA Driving School in the UK here, and I was working on a personalization website, and we were using there's something called the idol module within Amazon product. And what that does, essentially, it looks at your browsing history to recommend you what you should buy as well. So many e-commerce platform already has something like this, where they will say the person that bought this also bought that. So that's some sort of product recommendation. Also, if you have lived in the Western world, you will know that there is a lot of dependence by everyone on the weather forecast. Now, whether the weather forecast is accurate all the time or not is a separate conversation, but predicting future storms availability is something that has been around for a while. Again, that just shows you that AI has been around for a while. It's just that in recent times, because of ChatGPT, things have just gone crazy in the market. But those who are prepared to ride the waves and that can prepare themselves will not be left hanging by the thread. Let's look at what AI can do. AI can do what we call predictions and inferences. AI can do pattern recognition. AI can do optimization and automation. So, what is prediction and inferences? Prediction and inferences are 2 different things. Remember that AI uses machine learning to build systems that, based on data, learn to make predictions or inferences so that it allows us to learn from the past. So, what's a prediction? A prediction is that which forecasts something that is yet to happen. For example, as I mentioned this before, the high precision weather forecast, like the UK weather forecast, is a prediction. That is something that AI can do. That's something that we are already familiar with. Again, it might not be in the way that we now understand AGI and generative AI, but we're going to get there in a moment, all right? But this is what AI can do. It can predict the future. It can predict or forecast the future as something that's yet to happen based on historical data. Now, inferences determine a target output based on a set of inputs or predictors. So, an example of an inference is when AI, based on understanding your customer preferences and historical information, suggests to you the kind of music you should listen to. So essentially it's making inferences from known behavior. That is what an inference is. Prediction is about predicting what is yet to happen based on the data that has been gathered in the past. Pattern recognition. Pattern recognition. What is pattern recognition? This is when data is analyzed to find patterns in it so that you can then make decisions. So AI will look through the data, find patterns in the data, and then help to make decisions. So in order to achieve this, there are three things to pay attention to in pattern recognition. Number one is a term called clustering. What is clustering? Clustering is when you segment a group of data based on similar characteristics. So let's say, for example, a person is exposed to the AI is exposed to a lot of balls, red balls and blue balls and green balls. The AI is able to cluster the balls now based on color, right? That is clustering, and therefore is able to make decisions. So if you want the AI to determine probability of the red balls being chosen, the AI first of all will have to walk through the group of data, check through the color as an example of clustering, cluster them by color, and then do its mathematical computation to find out the probability of a red color being chosen. That is what clustering is all about. Anomaly detection. This is when AI identifies data occurrences that deviate from the normal. Let me give you an example. Have you ever tried to make a payment in your bank before? Let's say you want to pay $10,000 and you have not usually made that kind of payment before, and all of a sudden the bank blocks your account, they flag it up for fraud, and then you had to call them to confirm that actually that is not the case. Essentially that's an AI system doing that. What it does essentially is found out that your $10,000 that you are trying to pay out to somebody is a deviation from the normal way in which the account is being run. Maybe normally you only spend $500 regularly. Then it says actually you're spending much more money than what you normally would spend. It flags that as an anomaly. So that's what we call anomaly detection. The last point I want to make here on pattern recognition is data generation or generative AI. So generative AI really is when new data is generated based on existing data patterns from text, images, and sound. This is where ChatGPT comes to play, right? It's about you pump something in and that pattern is analyzed and new information is now generated based on that. So this pattern may come from your text, may come from images, and may come from sound, right? So that is what we mean by pattern recognition, recognizing patterns in what has been submitted to just create something new. Optimization. This is finding the most efficient possible solution given some constraints. This one actually I have an example that we have used before on one of my projects. We were working with this company in the US called Londra, and we were trying to do Uber for fashion. And one of the things that we have to do is to get the driver to deliver the cloth to the laundry at the uh, at the using the best route possible. So in finding that best route to get a driver to get to the laundry, we're optimizing the route. Okay, so and that is what AI does. AI does optimization. An example is Uber Eats, right? Uber Eats tries to find the optimal route to deliver the food to the customer from the place that it was ordered from the restaurant to the customer. You will look at traffic congestion and plan the best optimal route to get there. That's what an AI can do. You also have, if you have also bought flight on booking.com before, you can see that there's times when they are running discounts, or they are giving you dynamic pricing strategy, that you can go on this website, the price you find on the particular browser at a particular IP is different from the price you find at another IP address with another browser. It is because they are optimizing the pricing strategy in the travel booking to maximize the revenue that the company is going to get. That's a thing that AI can also do. For example, when you go on Amazon and there are some discount campaigns that are run, especially maybe during Father's Days or Mother's Day or Christmas or whatever, to increase product or brand sales. That's something that an AI is, again, can do for you, optimizing sales. Or if there's a need to efficiently operate and control energy grids so that we are distributing the right energy to the right people to optimize energy consumption, again, you can use AI to do that. Automation. Now, automation is the ability of a machine to follow some rules to perform some given task repeatedly and autonomously. Now, the key word is repeatedly and autonomously. Repeatedly means it's done over and over again. Autonomously means without any human interference. Now, automation is not AI, because remember, AI must mimic human behavior, right? But AI helps automation in the sense that AI can be used to analyze and classify a batch of documents or photos. AI can be used to screen large number of job applications. And AI can be used as robots to manage groceries last mile fulfillment in the warehouse. So there's a link I have here which you can go to later. You can basically look at that and copy it and put it on YouTube at your own leisure. You will see it shows Ocado. Ocado is the UK food delivery business here, and how they use AI in their fulfillment center to essentially deliver food to customers. So in the warehouse, the robots will move one product to another, from one lane to another, and just move them into the truck, and they get that delivered to the customer. So that just shows you an example of what AI can do. AI limitations. What are the limitations that we can face in AI? Number one, lack of quality data to learn from. This one, I was actually talking to a friend of mine a few weeks ago, and I was talking about how there's a lot of hype now going on in Nigeria, for example, about AI in the Nigeria context. And my friend is one of the top guys in the country, and he said to me, "Yeah, but the challenge we have is we need data. We need quality data. That even though people might be talking about AI, or if you don't have quality data to learn from, then AI can only do so much if there's no data." When I was in uni, I studied computer science, and there's a term that you may have heard that were taught is called garbage in, garbage out, which means if if you load your AI model with crap data, you're going to get crap out of it. All right, so data is really important. Another point I want to make here is bias. On the top right hand quadrant here, there's something called bias, AI bias. What is AI bias? AI bias essentially is when AI produces output that segregates certain group of people based on the data that has been popped into it. So I know that one of the things that I read somewhere was about how was it Google's bird, that when it was first created and somebody put in did a research about certain people, and instead of it bringing the color, or the color of the skin of the people in like Caucasian, it was bringing out black people, which was different from what obtained really in reality. Essentially, that data is become biased. All right, and I know some other people complain about how initially when certain prompts were put in some AI tools for black people, it wasn't able to show them because the data that was used to prime that platform was not good enough. All right, so you can see that bias is a big problem. If you want to build an AI platform that will survive, that will be much more agreeable to everybody, you need to make sure that it has no bias, that the data that is being fed to it is good quality. AI also is limited because if AI encounters new situations that it has not seen before, essentially a new situation is presented to the AI that it has no information about, then it will not be able to help you. So this you may be familiar with. For example, if you have a chatbot that you are trying to ask questions from, and you ask some questions that is not in the database of the chatbot will say, I don't understand what you're talking about. All right. Why? Because it has no data that has been used to prime it in order for it to respond to you, to give you the information. All right. So new situations not seen before can be a limitation for your AI platform. And then last but not the least is AI cannot, as at today anyway, mimic critical aspects in social interaction. So AI at the moment lacks empathy. Again, remember AGI that I mentioned before. AGI is artificial general intelligence, where AI exceeds or equals human behavior. One thing that is lacking at the moment in most of the AI platforms out there is this social interaction, empathy. The things that has to do with emotional intelligence. AI does not have that, but it's not going to be like that forever. So we want to go into a new concept. Now that we've spoken about limitations of AI, we've spoken about what AI can do. I want to talk to you about predictive versus generative AI. This will actually help you to understand some of these scenarios that you may have encountered, to put things in perspective. So, what is predictive AI? Well, from the word predictive, it means it's able to make predictions, right? Remember, we spoke about predictions and inferences earlier. Predictive AI essentially is the AI that is used to make predictions based on what? Historical data, or is able to make inferences like classifying data examples based on previously classified labeled examples. So essentially this is talking more around predictive AI is more AI that does predictions and that does inferences. But notice for predictive AI, it is based on data that it has before. So when you are going to that chatbot and you're asking it questions that is not in what is being programmed for, then it cannot answer you. It will fall apart. It has a limitation in that space. But when you ask it questions based on what it's been programmed to answer, the data that it has been pumped with or trained with, then it's going to predict information for you. All right. Okay. Now, generative AI is creating new content. That is what makes generative AI a big deal compared to predictive. Predictive essentially works with data that is known and it does inferences and predictions. But generative AI actually creates new content. This content might be text, images, audio that is generated, and it is doing this based on properties and patterns of existing content. Up, you see the difference now. One is based on predictions and inferences based on data that it has been labeled, and it has been pumped with or trained with. Generative AI tries to create new content based on properties and patterns of this same data that it has been fed with. So on the screen here, you see certain examples and the pros and cons, or what I call the delineation between the two. So an example of predictive AI is foreign exchange rate forecast for upcoming seasons. So if you go to xe.com, X as in xylophone, E for echo.com, you can check the exchange rate on that platform. When I want to transfer money to other countries, I do check it out. Or you might even go to wise.com. It's plugging into some sort of rate algorithm that basically can forecast rates for upcoming seasons. That's predictive AI at work. An example also is product category based on known features. AI can give you categories of your product based on certain features that is already been labeled with, that is been known. That also can happen. Another one that is very popular here in the UK is house sale predictions. So if you go to zoopla.co.uk or Right to Move, I believe, or some of the other property platform, you can basically put some certain information in that platform and be able to check out how much your house is to be sold for. That is a predictive AI at work. So there's some example of predictive AI that you can look at. IBM's Watson Studio, Microsoft Azure machine learning. On the right hand side, let's look at generative AI. So if you ask AI, and if there's an AI that can create a fictitious picture of yourself performing surgery, that will be generative, because it's creating new content based on patterns in the data that's been submitted into it, or that it has been trained with. Another example is, if there's an X-rays and MRIs that are augmented. So X-rays and MRI images that are augmented or synthesized or reconstructed, or a report that is created about images. That is something that generative AI is going to be doing. To create and optimize an autocomplete code, that's something that generative AI is going to be doing. An example of this is Google's Bard, ChatGPT, DALL-E from OpenAI. Machine learning. So now I want to talk about areas and related disciplines of AI. There are a number of areas and related disciplines that AI will work with. There are some of them on the screen here which I will talk through. Number 1, machine learning. Number 2, deep learning. Number 3, knowledge representation and reasoning. Number 4, robotics. Number 5, computer vision. Number 6, natural language processing. And then there are other areas like data science, psychology, privacy, ethics, or law that are also important. So what is machine learning? Machine learning is the ability of computer software to learn from existing data by itself and identify patterns within that data to make predictions or other inference tasks. So when we talk about prediction and inferences earlier, that I mentioned earlier, these are all using machine learning algorithm to do that. So being able to know the kind of movie you should watch by Netflix based on your preferences, as a machine learning thing. All right. Okay. So that's just to give you an example in real world that you can really kind of relate to. Deep learning. Deep learning focuses on training neural network models to solve some of the most challenging AI problems. So deep learning, we're going to cover that later in this lesson. So I'll talk more about that later. Knowledge representation and reasoning. This is studying how to conduct logical reasoning over knowledge to communicate with other AI systems. Robotics involves building AI-powered machines that act and manipulate objects in the physical environment. So a drone could be an AI powered machine, as long as it's able to collect information and do what AI would normally do, right? Computer vision investigates how AI systems visually perceive objects in their environment. So a drone as well, we have an element of computer vision, right? Now robotics that I mentioned earlier, I think I will add that if you have in a motor assembly line, they use robots to assemble most of those body parts, right? So that is part of an AI element. NLP. This is the ability to analyze, understand, and communicate information in human language, such as text or speech. So an element of NLP is going to be used in ChatGPT. So other areas include data science. I'll talk about that later. the value of data in all of this is because data is the fuel of AI. Without data, there's no AI. AI cannot work properly. Then psychology. Psychology is what is used in NLP, right? So by understanding the human communication, yeah, you need to understand psychology to be able to do that. Now, remember I said earlier that AI has not evolved to the point where it can it can handle emotions, all right, but psychology is needed as well, understanding psychology. Then privacy, obviously we need to be careful about the data that has been collected. What's happening to that data. Are we still protecting data? Are we aligning with GDPR and other privacy laws? Ethics about using the data for the purpose for which it was collected. And then that is also an element we call responsible AI, which means AI has to be responsible. AI has to be used responsibly, right? And law, obviously, there, what anything you do that has to collect human data and work with human data will be subject to some sort of law enforcement. So let's look at an example, modern day applications of some of these elements of AI, so that you can know that actually these things have been around for a while. It's just that ChatGPT blew everything up, like I mentioned earlier. So, Amazon, for example, uses personalized recommendations, machine learning algorithm to learn customers' preferences and predict products that they might be interested in. Another example here is actually Netflix. Netflix uses or understands the movies you've been watching, your preferences, every interaction you have on that your Netflix app is actually training the algorithm to keep serving you what you want to keep watching. All right. So anytime you choose an interest, it records it and say, hey, this is what this guy wants. Let's serve him more of that. All right. Now, Okado's smart warehouse management system has robots that navigate the facilities, visually detect objects, and reason to communicate with each other and optimize operations. So we see here, this is robotics, right? This is an element of robotics that allows you to be able to do that. Computer vision and deep learning can help identify conditions upon images or video data such as X-ray radiography. So there's an AI platform called Light AI that can allow you to do that. All right. So I put the logo in there so you can remember that Light AI can use computer vision and deep learning to help to identify conditions and diagnosis. And obviously, our wonderful Siri on your iPhone uses natural language processing because it understands human conversation and deep learning to communicate with you. So when you say Siri, open up X, Y, and Z, Siri is using an AI element called NLP to be able to do that. So now, here is another test to test your knowledge. Identify which domains of AI is in use in the 5 scenarios below. So there are 5 scenarios below. We want you to tell us for each scenario what is the AI domain that is being used in that scenario. Scenario number 1. Review bank transaction data to learn patterns of the transaction so as to be able to determine patterns behind potentially harmful transactions and classify future transactions as secure or not. So this is about pattern recognition, right? You are recognizing pattern in data to help you to make certain decisions. So we're going to look at what domain that is. Number 2, process an input piece of text in Spanish and automatically translate it into Igbo language. Igbo language is one of the language in Nigeria. So, if somebody takes a text from Spanish and translates it to Igbo automatically, which part of AI is doing that? Log into your personal iPhone by scanning your iris. I told you earlier that now iPhone has got this thing where you can allow it to scan your iris in order for your phone to be unlocked. Number 4, autonomously assemble a piece autonomously assemble pieces for building a new car. That is assembling cars in the warehouse autonomously. What does that? Okay. And number 5, represent concepts and instruction to play a game of Monopoly in a way that the computer can understand and reason about. This is essentially allowing the computer to understand the game of Monopoly and the way it is being played so I can reason about it. All right, let's look at the answers. Wow, the first one is machine learning. The second one is NLP. Third one is computer vision. The fourth one is robotics. And the fifth one is knowledge representation and reasoning. So, how does AI acquire data? AI collects data based on what we call sensors. And these sensors emulate the 5 human senses. And this information collected will now be turned into data. For example, natural language processing and audio capture speech and sound. So an AI can acquire data by collecting speech and sound. An example is your Siri. When you say Siri, find me this movie, is collecting that speech and sound from you. Computer vision capture iris scan or fingerprint. So every time you use your face or your iris to open up, to unlock your phone or your iPhone, the iPhone has an AI intelligence that is collecting that data from you. And if you have lived in a smart home before, where you can control the temperature of your home from very far distance, actually is a form of AI that is based on robotics that's helping you to capture the temperature levels in your house. So let's go back to the way AI learns from data. AI learns from data in four primary ways using the machine learning concept and deep learning concept that we mentioned earlier. The four ways are supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. Let's now go into supervised learning to know what that is all about. Supervised learning is when the machine is trained using labeled dataset. Remember, we said dataset will be what? A collection of data that is being used to train the machine or the AI in this case. And that data set could be data samples, it could be observations, it could be instances of a certain type of data. So the data could be structured and it could be unstructured, it could be labeled or unlabeled. I hope that making sense. So your images, your songs, your videos, your document, the collections, and so on and so forth are data sets. At the same time, your Excel spreadsheet, data in your databases are data sets. I hope that makes sense. So now when we say we are using data sets that are labeled, that's what we're using to train the machine. Then what we're doing there is the machine is undergoing supervised learning. That way, based on the training, the machine can predict the output. So the labeled data set specifies that some of the inputs are already mapped to the output. So when you chat with a chatbot that can refer information from you based on what it has been trained with, that chatbot has been trained, has been supervised. Okay, so we train the machine with the input and the corresponding output, and then we ask the machine to predict the output using the test data set. So real world applications for supervised learning are things like risk assessment, fraud detection, spam filtering. We'll talk more about this in the next slide. Unsupervised learning. The machine is trained using unlabeled data set and the machine predicts the output without any supervision. Now, that's an interesting one because now you have unlabeled data set that has been given into the machine and then you are leaving the machine unsupervised to work out which one you should go. So before we go into this, what do you think in your own mind will be the best way to do this? Imagine you are, excuse me, you are a machine and you have been pumped with a series of images. In order for you to be able to output the right information, what do you think you need to do first? I guess you need to find patterns, right? You need to classify them, you need to group them into patterns. That's exactly what unsupervised learning does. The model groups or categorizes the unsorted data set according to similarities, patterns, and differences because the model has been instructed to find the hidden patterns from the input data set. The next one we want to look at is semi-supervised learning. Here, machine learning algorithm blends supervised and unsupervised learning together. So this is like a halfway house between supervised learning and unsupervised learning. So essentially you have a set of the data that is labeled, you have a set of the data that is not labeled, and you're trying to get it. Reinforcement learning. Reinforcement learning works on a feedback-based process in which an AI agent automatically explores its surrounding by hit and try, taking action, learning from experiences, and improving its performance. In reinforcement learning, there's no labeled data like supervised learning, and agents learn from their experiences only. So an example of how you learn from experiences, you as a child, when you're growing up, if you have a child, you learn how to ride a bike, you fell down a couple of times, you know how not to do it like that. So you learn from experiences, right? That's how you learn. So every time you learn, every time you have an experience and maybe it didn't work and it worked, you learn from it, and then you use that to build up your muscle or build up your thought process or the way to do things from that point forward, right? So the key thing is the feedback you get helps you to improve, all right, so that you get better as time goes on. So let's look at another object under artificial intelligence. We spoke about machine learning. Now I want to talk about deep learning. Deep learning is, because it's using neural networks, is handling things as much more complex than even what a machine learning thing would do. It's able to recognize objects in videos. It's able to translate and summarize its text. It's able to generate realistic conversation images and songs. Some of the latest development in ChatGPT or DALL-E or any of these things are actually, using a form of deep learning, because it's able to do things that goes beyond machine learning. So the neural network ability that it uses helps it to be different from machine learning, but it is a deep learning is under machine learning. How that makes sense? Computer vision. One way in which you can understand computer vision is this. If you have ever used your photographic filter on your phone or Instagram, is a type of computer vision where the image is processed intelligently. So it allows you to enhance the images that you have stored so that it can be displayed in a different way. If you have used DHL before, and you have used them to track your package as it's being delivered, is an example of object detection example, which uses computer vision. So computer vision under object detection identifies subjects in images and video for surveillance and logistics. So if you have your CCTV camera and you're able to identify somebody in a group of people, that's object detection example. So this one you should easily relate to, because if you're watching some of these spy movies, you will notice that if a target has been acquired and this target is being looked for, maybe by law enforcement agents, in a group of people, that person can still be identified because that image of that person is being scanned by the CCTV, right, to pick that person out. Motion analysis example. This is when the AI extracts motion information like speed and direction of objects from object that is in motion. An example is drone. Drone is being used extensively now, not just to deliver packages, but to do reconnaissance and surveillance activities. And finally, image video generation. So an example of that is an avatar, right? So these days you can create realistic visual data from human text. There are AI platforms that when you put your human text in it, you can create visual representation out of that. So I know that I've seen a number of AI tools out there where you put in a text of show me the way I'm going to be in 50 years, and it show you a different kind of image Obviously, the image doesn't look like you 100%, but it's an enhanced image. That's a bit of computer vision that's working on that data. NLP, natural language processing. Natural language processing is the ability of a computer program to understand human language as it is spoken and written, and it is referred to as natural language. It's a component of AI. NLP has existed for more than 50 years and has roots in the field of linguistics. So, an example of this NLP would be classifying text, sentiment analysis, for example. So essentially, when customer leaves a review, we can go through and figure out what are they really talking about. What's the sentiment behind the review? Okay, chatbot obviously uses NLP. Text summarization, and then we say text to speech or speech to text. Text you convert to speech, speech you convert to text. It's form of NLP. So you can see this NLP technique domain in use in some of these AI that are being used to take notes, like note-taking AI app. They are actually using natural language processing because they will be those apps will be listening to what you're saying in the meeting, and they will record everything and then do the transcription. Some of the tools that I use even now to do some of my videos are using NLP, because you have a podcast that you record, the tool listens to what you're saying and does the transcription automatically. So that is text to speech or speech to text. Robotics. That's the last thing we want to talk about. Robotics essentially is just robots, right? Something that is a machine that is created in a physical environment, right? That helps to do what humans cannot do, or do what humans cannot do, but do it more efficiently. So, example of robots are drones that are used to capture aerial images, mobile robots used in manufacturing, robotic soldiers. These are soldiers that are robots that have been developed by the government to go fight war. Industrial robots that are assembling cars. Humanoid robots is a robot that mimic human behavior and speak just like a human. It can do what humans do. That's what humanoid robots are. So now that you understand um, the domain of AI, we want to now move into, if you want to build an AI-driven organization, you're asked you get a new job. In that job, you're asked to contribute to the build of an AI-driven organization. What are you going to do? There are three fundamental pillars to pay attention to. One is the business element. Second one is data and infrastructure. And the third one is people and culture. Under the business pillar, we have the AI roadmap, which is what's the roadmap for AI in this company. Second one is AI success management. How do we measure success? What does success look like after we've delivered it? The under data and infrastructure, we're looking at the data strategy. Do we have data to underpin the AI that we're trying to build? Do we have the appropriate level of governance to ensure that that data is preserved? Do we have the infrastructure resource? Do we have servers and databases and network and so on and so forth that have enough compute power to be able to help us in the computational requirement of our AI that we're trying to build? What about responsible AI? In which way are we going to use AI ethically? Then people and culture talks about the roles. What are the roles involved in an AI organization? What are the AI roles that we need in our project? What are the collaborators that we need to be involved with? And then, do we have an AI literacy or data literacy culture? Do people in our company understand AI, understand data? If not, what are we going to do about that? Now, let's go into AI roles. What are the roles that we need for our AI project? There are three axes or three levels or three fulcrum or three pillars under roles for AI. The first one is leadership and management roles. Second one is execution roles, and third one is support roles. Under leadership, we have two types of roles. One is the AI project manager. The role of the AI project manager is to lead the AI project, just like any other project. And then you have the AI team lead or AI manager. And the role of the AI manager is to function as the AI strategist. This person is actually thinking about, the use of AI in the company, how is that going to work, and so on and so forth. Then under execution, we have the AI architect. All right, these are the people that select the tools to use for your AI project. What tools are we going to use? What infrastructure? What infrastructure are we going to use? And so on and so forth. All right, so that's the job. It's about selecting toolings to use. The data scientist analyzes data and trains that data and evaluates the model. So the work of the data scientist is to, analyze the data and use that data that has been collected and analyzed to train and evaluate the model. What about data engineers and machine learning engineers? They deploy the model into production and build data pipelines. What about the support function? There's a role called AI ethicist. This person ensures ethical use of AI. So you need this person from the beginning to ensure that whatever you're building does not violate privacy law and all that stuff. And last but not the least, you have domain expert. Domain experts are SMEs that are in the business, and it also includes functions like business analysts. And the role of them is to provide support to the overall program to ensure things are done appropriately. AI lifecycle looks like. So this one I'm going to spend a minute to just explain it, but I'll come back to it at the end of the introduction to then deep dive into what each of these elements means and what you can do about that. So suppose you are asked to come and deliver an AI project. Say for example, an AI chatbot. Deliver an AI chatbot. What will you do? There are 6 levels or 6 phases that you have to go through. The first phase is problem definition. Problem definition means you want to understand what the problem is. After that, you acquire data acquisition and preparation. After you acquire data, then you would develop the model and train that model with the data that you have acquired in the previous step. Then that model will be evaluated, which means to be tested by people, and they will give feedback and recommendation, and that will use that to refine the model. Then the model is deployed, and then you move into MLOps, machine learning operations. So if you look at this life cycle, it is easy to see how this kind of maps out with your any project life cycle. So for example, problem definition will easily map into the discovery phase of an agile project. Data acquisition also will map into the discovery phase of an agile project. Model development and training will map up to the alpha phase of an agile project. Model evaluation and refinement will map up to the beta phase of an agile project. AI model deployment will map up to going live or deployment, of an agile project. And then machine level operation will be post deployment, which is you are now in operation. You can also map this to your project phases, standard project phases like initiation, planning, execution, deployment, and post deployment. All right. But the key thing to take away here is when you join a company and they want to work on an AI lifecycle or an AI project, you need to know this. You need to define the problem, because it's not every problem that can be solved by AI. So the purpose of problem definition phase is actually to check whether that problem can be solved by an AI tool. All right. And then if that is the answer, then you go and say, do we have the right kind of data that we need to acquire that we can use to train the AI before we start building AI? There's no point in building an AI platform that you don't have the requisite tool to use to train it. So you go and acquire that data, you prepare the data, right? And then you move into developing the model, and then you train the model with the data that you've collected, and then you hand that over for evaluation and refinement. So for example, even ChatGPT that has been released into live platform is still being trained by the data that you are pumping into it. Every single time you go to ChatGPT and you ask question, you are using that to train the model over and over. Now, you could say ChatGPT has been deployed into live, which is AI model deployment, and there is probably is in MLOps at the moment, but the cycle continues. You keep on going and refining what you've done until you finish it. All right. So at model evaluation and refinement, you are testing the model and then you deploy it when it's okay for it to be deployed into a live environment before you then move into machine level operation, which is MLOps, which is how you constantly improve what you have deployed. We are going to cover this in future lesson. So let's look at an example. This is what I call a teaser page. The purpose of a teaser page is to help us to tease out whether you understand what we have just covered based on the AI project life cycle that I've just covered. I want to see whether you understand how you will try and organize certain steps in an AI project if you were given a chance to do it. So this one we call it help me build an AI tool by figuring out the order of work. So you have been asked to develop an AI-based workflow for the NHS in the UK that will diagnose accurately COVID via machine learning algorithm from historical patients' data. In what order do you think this workflow should be developed? Number one, we should collect medical history data. Number two, output diagnosis. Number three, reason and analyze new patient data. Number four, organize data and feed this to the AI system for diagnosis. Number five, initiate treatment based on diagnosis. Number six, determine if AI workflow is a right solution. What do you think the answer will be? Let's go in the next slide to find out what. So the answer is this is the order in which you should do it. Determine if the AI workflow is the right solution. That maps up to our problem definition step in the AI lifecycle. You need to know whether the AI workflow is the right solution for this problem. Then you acquire data, collect medical history data. That data is organized and fed into the AI system for diagnosis. So you acquire data and then you do what you model, you train the model now with the data. Now reason and analyze new patient data. Once that model outputs that information out, you are going to take it through refinement, right? Okay, and that is what we call model refinement, right? Then output diagnosis. This is when you go live with the diagnosis. So this is like going live, deployment. And then step 6 is initiate treatment and based on diagnosis. That is your MLOps. So this is how you kind of just map that together. If you got this right, then you have gotten what you've covered so far. So I want to thank you very much. So now, so in this slide, I want to look at the AI life cycle and how that aligns with the agile phases. So remember that because AI requires a kind of cultural mindset shift that is based on agile, not traditional. Therefore, the best project life cycle to adopt is that of an agile delivery framework. So what we've done here in this slide is to look at the AI life cycle vis-a-vis how that maps with the agile phases. So now in agile phases you have discovery phase, alpha phase, beta phase, live phase, and post implementation support phase. So the items in the blue on the outlier of this concentric circle is what I'm talking about. Those are the agile phases. While the concentric circle are the items that we have in AI life cycle. So when you are trying to do a mapping between the AI life cycle and the agile phases, the way to do it is to align this discovery phase of an agile framework to the problem definition phase and data acquisition phase. Then in training the model and developing the model, that will be part of the alpha phase. Now in the alpha phase in an agile project, that is when you are basically trying to do a kind of POC mock-up. Basically you're trying to develop what the customer wants, but you are exposing that to the development teams to just test that and make sure it works. And that's why that aligns with the model development and training, because this is something that you're doing with the AI core team to develop the model and train the model with the available data that have been acquired in the preceding steps of the AI life cycle. All right, so discovery phase in an agile phase is about understanding what the customer want, doing things like your stakeholder analysis, assist and to be process, gap analysis, all the standard stuff you do. And in a discovery phase, you do that here. And so that's why this aligns with problem definition and data acquisition phase. In the alpha phase, you start development with clarity around the requirements that have been gathered, and therefore that will line up with the model development and training, because here you are priming the model, you are training the model with the data that you've acquired. And in the beta phase of the agile framework, we align with model evaluation and refinement for our AI lifecycle. In the beta phase, normally what you're doing is you have now delivered the work that you've done in the alpha phase. Now you are going to start conducting user acceptance test, where you get the business to come in and actually test what has been developed in readiness for go live. All right, so also in beta phase, you're going to have items around test scripts, test cases, UAT plan, UAT execution, which are all testing and validation of the work that's been done in a traditional agile phase. That's what you'll be doing here. In the AI lifecycle, you are going to be doing evaluation of the model, which essentially is a form of UAT. You are testing the model, and the feedback from it, you are using that to refine the model until it is okay. Then you go into AI deployment, which is in AI lifecycle, you are now deploying the model into a live environment, which is synonymous to going live in an agile phase. On the back of that, you move into machine learning operation, which is essentially now this AI is now in operations, which will require a number of tasks to be done around machine learning to operationalize the AI, get feedback, and keep training it even when it's in production phase. We have covered MLOps before, so that should give you an idea around what we are doing here. And that aligns with post-implementation support, a framework for an agile phase. So essentially you have delivered what the customer wants using an agile framework, and it is now in production. How and what do you put in place to support that deployment into production so that it can continue to be operationalized and without causing so much problem? So that's what we do in this. So this essentially is to show you how the AI lifecycle and the agile phases are kind of lined up together. The primary problem that the company is trying to resolve is defined in problem definition phase. So we're going to use an example of Amazon product recommendation AI project to explain each of these steps in the AI life cycle. So problem definition, we want to understand the problem statement. What is the problem statement for Amazon? Well, Amazon wants to improve the accuracy of product recommendations and thereby enhances the shopping experience for users while driving increased sales. So that is what they are trying to achieve. The question now is, to achieve this, do they need an AI system? And the only way to do that, to answer that question, is to carry out what we call an AI suitability assessment, which I'm going to cover later. But that's what you do under problem definition. Then you move into data acquisition and preparation. Here, what will Amazon do? Amazon will collect vast amount of data, including browsing history, purchase history, ratings, and so on and so forth. These data points can be identified as a critical information needed and collected and prepared for the model development phase. In model development and training, Amazon uses many machine learning models, such as collaborative filtering, to create their recommendation system. Their models are trained with the prepared data to predict a customer's interest based on similarities with other customers. So essentially, the data that's been collected in step 2 is used to develop the model, and then but the model itself uses other models to create a recommendation engine, and that data is then used to prepare that engine. That's essentially what they're talking about. Then model evaluation and refinement. The model is tested extensively and its predictions are compared to actual customer behavior to evaluate its efficiency or accuracy. Remember, when we're talking about model evaluation, we spoke about two things that are used to test or evaluate a model. One of such is accuracy, the other one is error, if you remember. Okay, so here it's saying the model is tested extensively and its predictions are compared to actual customer behavior to evaluate its accuracy. So it's testing for accuracy. Based on this test, the model is continually refined, and improved to increase the precision of its recommendation. Then once we see that the recommendations are precise, we deploy it. So once the recommendation meets the performance benchmark, it's deployed on Amazon's platform. The model now operates in real time, right? Suggesting products to users based on their browsing and purchasing behavior. Number 6, MLOps. Post deployment is the model in post deployment, the model is continually monitored and updated as user behavior and preferences evolve over time. The model is retrained and updated to ensure its recommendations remain relevant and accurate. So now we get into the phase where I now want to talk to you about what do you do as a business analyst in the discovery phase of an agile project, which is used to deliver an AI project. Essentially, we're talking about what does a business analyst do during the problem definition phase of an AI life cycle or of an AI project, which, as I said in the previous slide, the problem definition phase aligns with the discovery phase of the agile project life cycle or agile project framework. Some of the things that the BA would deliver will include the following things: the business case document, which is why you're trying to get the rationale for the AI project. You're going to look at benefits and costs and return on investment. The stakeholders that will be involved here will be the project sponsor and the executives and other stakeholders. Then you develop stakeholder analysis. Basically, you talk about who are the stakeholders, what do I need to know about them, what is their interest in the project, what's their power. So you set up with the power interest grid of a stakeholder map here, and essentially what you're doing here is you are identifying stakeholders, their interest and their influence in the project. Then you go in and start some requirement documentation. Requirement documentation here is going to be at a high level, where essentially you want to understand what does the customer want. Now remember, I shared earlier that the problem definition phase of the AI lifecycle is about understanding the problem statement, and then at the end of that you want to do an AI suitability assessment to check that that problem that we now know we have clarity around, that the customer says he or she has, is it AI that will be the right solution for it? That's ultimately what we want to get at of the problem definition phase of the AI life cycle. So when we're guiding requirement here, we're guiding requirement based on understanding clarity from what the customer wants. So we are detailing the business functional and non-functional requirements here. And again, now here we can write this requirement in user story format. We can put them all in Jira. That's still okay. All right, we can define acceptance criteria for each of these requirements. That is perfectly okay. And one of the things we also do is feasibility study. So what's a feasibility study? Feasibility study is essentially a document that is created that talks about whether it is feasible to actually carry out the project, to solve the problem that the customer wants. So when you've carried out a feasibility study, you then develop what we call the AI suitability assessment. Now, as a business analyst, it is your job to run the workshop, to be able to gather this assessment. This assessment is based on a few questions and criteria that the customer has to meet in order for the customer to be approved or deemed ready for using AI to deliver the solution to the problems that the customer has. Now, as a business analyst, it's your job to do that. Now, obviously, in this particular module, we will not be looking at this. We're going to be looking at this, the detailed steps on how this is done in the next module, which is the second module for the AI lifecycle delivery, which is beyond the scope of this particular video. So the AI suitability assessment is a framework or set of criteria used to evaluate whether a particular business problem or process is suitable for an AI-based solution. So the business analyst will do that work, and also representative from the legal team or tech team and privacy team and so on and so forth, to ensure that we have a holistic view around what needs to be done. So this deliverable matrix that speaks about what a BA would do is very important, because it's essentially showing you what you would do as a BA when you are delivering an AI project, and you are doing that within a tandem of an agile framework. All right, thank you so much. So now in this slide, I want to just begin to round up this module entirely, but I want to call out a few things that I believe will help you as well in your work. So suppose you are not even called to work on an AI project, but you want to find out if there are AI tools there as a BA that you can begin to leverage on, that can help you to do a better job, a quicker job, make you to become much more efficient. I've got a few ones, just random ones from across discovery and alpha phase of an agile project, or problem finding and model development and training phase of an AI life cycle. So you can use ChatGPT, for example, to build up your business case. You can use ChatGPT as an AI tool to develop your stakeholder analysis. You can use a platform called Reloom.io to build up your wireframes and your mockups, which gets done in seconds. And then you can also use a website called userpersona.dev to build up your persona for your type of customer that you're going to be trying to solve their problems. And then you can also use a tool called visily.ai for your user interface design. So now, as we get ready to round up the program, I want to bring to your awareness what the next steps look like for you. As you've covered in this extensive course on the rise of the AI business analyst, where I spoke a lot about the artificial intelligence and what that means for the business analyst, and generally what that means for every single professional. I think what the next step looks like for you as a business analyst is to see how you can partake or be part of the 5-day framework that we have created and put together to help you know what you need to do to manage an AI project, and also the kind of tools you can use from today to improve yourself, to make yourself much more efficient than those who haven't taken this course. So Day 2, day 3, day 4, and day 5 is about going through the work that a BA would do at at discovery phase, alpha phase, beta phase, go live, and MLOps phase of an AI life cycle. And then the last day is to look at your profile, walk through with your CV, and help you to prepare yourself for the marketplace. If you are interested, please go to the link at the bottom here is davis.bamigboye.com/the-AI-BA-bootcamp. If you go there, you'll be able to see the next coming bootcamp date there, and then we'll be looking forward to support you in your AI journey. Thank you for giving me the opportunity to mentor you briefly through this course. I know it's taking a bit of time to go through them, but I hope this has been very useful. Please remember those AI tools that I mentioned in the previous slide. You can just go to the internet or the website and put those names there, and you can just play around with them. It's pretty straightforward. Wireframes can be generated in seconds. Same thing with sitemap. Same thing with persona. same thing with business case document and stakeholder map when you use those AI tools. So life is getting better, everyone. So you just need to take advantage of that. Until next time, remember, my name is Davis Bamigboye, and it has been a delight working with you on this module. Clarity around what the bootcamp is all about, whether it is for you or not, please go onto that page, davisbamigboye.com/bootcamp-clarity-call, and book a slot, half an hour slot with one of our coaches, and then we can sit down together and look through whether we're a good fit for you, and also to answer any of the questions that you may have. Thank you so much.